Good morning. We're going to cover the last part of section 6.6, solving exponential equations. I guess this is going to be part 3 of my videos. I'm going to cover Newton's law of cooling. Go ahead and write down the equation. Looks complicated, not complicated once we go through all the parts. Okay, T sub 0. This is the initial temperature. So I guess I want you guys to think about like cooking. You can calculate how long it's going to take for something to get to a certain temperature. So many different applications for that because there's, obviously steel and food and plastics and almost everything that you create, you have to heat it somehow. And then you have to cool it to a certain temperature in order to make certain things work. It's engineering, lots of engineering. Okay, T sub R is a surrounding temperature. Just take that into account. What's R? Rate. What's T? Time. What's E? Yeah, Euler's number, right? Okay, so let's look at example 2. You are cooking. Ooh, what is a licha? You're cooking a licha. Let me put it under here. Obviously, you wouldn't be calculating this when you're cooking, but the people that make recipes and cookbooks, they're the ones that are going to be the people that are making the recipe. They're the ones that do it. You're cooking a licha, an Ethiopian stew. When you take it off the stove, its temperature is 212. That's the initial temperature. The room temperature is 70 degrees Fahrenheit. And the cooling rate of the stew, and they give it to you as a decimal, 0.046. How long will it take the stew to cool the stew to a serving temperature of 100 degrees? So restaurants too, you gotta make sure that when you serve something, coffee shops, that it's not too hot. You serve things that are too hot, people get burned, lawsuits happen, and get ugly. Let's write it down again. And then we're going to plug everything in. Why is it a negative? Negative RT. Yeah, cooling down, temps going down. So there's a growth or decay. Hey, yeah. That was on your quiz. People are listening. What's the initial temp of the stew? 212. Where do I put that? T sub 0. What temperature do you want to serve it? 100. Where do we put that? T in the beginning. That's what we want. 100 degrees. Temperature's been very sensitive. I've been like more aware of it recently because I've been trying to make candy. Candy making and caramel, hard caramel, and it's very difficult. You have to get it to a very specific temperature, without burning it, and it's very difficult. Candy making is very difficult. Obviously, as a new person who hasn't done it, but I've been trying. I failed a couple times. One batch was kind of good, but then it's a very difficult thing. I realized. Okay, what's the surrounding temperature? 70. So plug that in. T sub R, so that's the surrounding temp. E, what's the rate? So negative, make sure you put that negative in there, 0.046. T plus 70, yeah. And then you're like, wow, I'm looking for this up here. That T, how do I get that T by itself? So we're going to use some of our Algebra 1 skills to isolate it so it's just the E. And then once it's just Euler's number, what are we going to do to both sides? Yeah, we're going to natural log both sides to get rid of that E. Okay, so let's do our Algebra 1 skills. Okay, what's one thing we can do? We can subtract that. What else can we do? Subtract what? The 70. So we can subtract 70 from both sides. That becomes 30. We can subtract inside the parentheses, which is 142, e to the negative 0.046t. Can't natural log it or log it until the e is by itself. So what am I going to get rid of? 142 by dividing 142. So algebra 1 skill, super strong here. And this comes out to be 0.211. Still want to be solving for t. We're going to natural log both sides. Natural log 0.211 equals natural log of e to the negative 0.6t. Okay, what happens? Yeah, this cancels out. Go ahead and put in your calculator. What's the natural log of 0.211? Negative 1.556, good. That's going to equal negative 0.046t. Last step, divide both sides. Find out that your time is approximately 33.8 minutes. It's about 34 minutes. Big in the restaurant field, because you know there's a wait time, and then there's a wait time that's too long for customers, a wait time, but then you can't serve it yet until it's cool enough to eat. Questions? I want you to practice. We're going to practice the Newton law of cooling. It's in the big idea of math. I think I gave you 2 or 3 problems on that. Okay, go ahead and flip the page. We'll do the last part, which is inequalities. Same thing as the equation on page 337. B to x is less than 20. Okay, more review, right? More review from what we also just did on the quiz. I want to get to that x. How do I get rid of that? What do I got to get rid of? I'm going to log it because I'm going to get rid of the 3. So I'm going to log base what? Base 3. So log base 3, 3 to the x. So log both sides. Cancel this out. X is less than log base 3 of 20. And all you do is you put that into your calculator, graphing calculator, so you can change the base. And then it gives you a number. So that means that x has to be less than 2.737. It's so easy. I think that's why I didn't put it as part of my first 2 videos. Let's do example 6. Let's do a log. Log x less than or equal to 2. What kind of log is this? Common log. Good. What's the base? 10. How are we going to solve it? Fancy word. Exponentiate. We're going to exponentiate each side by 10. Cancels this out. X is going to be less than or equal to 10 squared. X is going to be less than or equal to 100. It's really easy.